Question 3, Part B. Let A and B be the points 0, 1 and 2, 3 respectively. Part 1. Find the coordinates of the midpoint of AB. To help with visualization, I've sketched a number plane and shown the 2 points A and B roughly located on this number plane. So here is point A with coordinates 0, 1, so it happens to be a y-intercept of the line through AB. And here is point B with coordinates 2, 3. I've let capital M represent the midpoint of AB. And I'm going to show that also by drawing these dashes here as well, so to indicate that AM is equal to MB. Now to find the coordinates of the point capital M, which is the midpoint of AB, we find the average of the x coordinates of A and B, and then the average of the y coordinates of A and B. Now the average of the x coordinates, 0 plus 2 over 2 gives us 1, and the average of the y coordinates, 1 plus 3 over 2 gives us 2. So the midpoint of AB has coordinates 1, 2. Part 2. Find the slope of the line AB. The slope or gradient of the line through points A and B is given by the formula change in y divided by change in x, otherwise known as rise over run. Now from left to right, the change in y, or the vertical change, going from 1 to 3 is given by 3 minus 1 in brackets, and the change in x, starting from 0, ending up at 2, the change in x is the difference between 2 and 0, so 2 minus 0, and that gives us 2. So 3 minus 1 in brackets divided by 2 minus 0 in brackets gives us 1. Therefore, the gradient of AB is 1. Part 3. Find the equation of the perpendicular bisector of AB. I've indicated the perpendicular bisector on the diagram. It's a line that passes through the midpoint M of AB, and that's why it's called a bisector, and it's perpendicular because it's at an angle of 90 degrees to the line that passes through AB. Now firstly we need to find the gradient of the perpendicular bisector, and that's given by -1 divided by the gradient of AB, which we found in part 2. And that comes from the formula M1 times M2 equals -1, where M1 and M2 are the gradients of the two lines that are 90 degrees to each other. So -1 divided by 1 gives us -1. Next we need to consider the point that this line passes through. So the perpendicular bisector passes through the midpoint, which has coordinates 1, 2. So using the point gradient formula, that's y minus y1 is equal to m times x minus x1 in brackets. We have y minus 2 is equal to -1 times x minus 1 in brackets. Expanding the brackets, we get y minus 2 is equal to -x plus 1. And then rearranging this equation into gradient intercept form, we get y is equal to -x plus 3. Part 4. The point P lies on the line y equals 2x minus 9 and is equidistant from A and B. Find the coordinates of P. Since point P lies on the line y equals 2x minus 9, this implies that P has coordinates x, 2x minus 9. Now it's given that point P is equidistant from points A and B. That means the distance from point A to P is equal to the distance from point B to P. So this means that PA is equal to PB. Now thinking ahead, we will need to use the distance formula, and that involves using a surd or a square root. But in order to avoid using the surd or the square root, we could make it a little easier to apply the distance formula if we square PA and PB. So if PA is equal to PB and they're both positive values, we can square both sides of the equation, maintaining its integrity. So PA squared is equal to PB squared. So using the distance formula, or the square of the distance formula, so we don't have to use the surd or the square root, we have x minus 0 in brackets squared plus 2x minus 9 minus 1 in brackets squared is equal to x minus 2 in brackets squared plus 2x minus 9 minus 3 in brackets squared. Now x minus 0 is x, so x minus 0 in brackets squared simplifies to x squared. 2x minus 9 minus 1 simplifies to 2x minus 10, so we have 2x minus 10 in brackets squared is equal to x minus 2 in brackets squared plus 2x minus 12 in brackets squared. Now expanding the brackets here, here and here, so using perfect square expansion, we get x squared plus 4x squared minus 40x plus 100 is equal to x squared minus 4x plus 4 plus 4x squared minus 48x plus 144. Now we have some cancellation. We can cancel the x squared here and here. We can also cancel the 4x squared here and here. So that leaves us negative 40x plus 100 is equal to negative 52x plus 148 after we collect like terms. So we have a plus 4 and a plus 144, and that's why we get the plus 148 there. Also, we get the negative 4x minus 48x, which is why we get the negative 52x here. So rearranging this equation, again, collecting like terms further, we move the x's over to the left-hand side and the constant terms over to the right-hand side. We get 12x is equal to 48, which means x is equal to 4, and that's the x-coordinate of point P, but we also need the y-coordinate. Now, it's given that y is equal to 2x minus 9, and that's the y-coordinate of point P. So given that x is equal to 4, which we just found, y is equal to 2 times 4 minus 9, which equals negative 1. Therefore, point P has coordinates 4, negative 1.